Hey guys, welcome to this video. So in this video I'm just going to walk you through the part 2 of AWR interpretation. So hope you watched the part 1 section. So hope you liked it, and if you like the video, just subscribe and comment on the part 1 of the video. And based on your response and support, I would further put more videos on AWR and also in-depth and individual issues as part of AWR. So as of now, I'm just giving you a high-level basic explanation of the AWR sections. Okay, so based on the support, I would further get motivated and put more secrets on each and every individual issue, so that it will be helpful for your day-to-day activities. Okay, so definitely you would face any one of the issues during your performance interpretation journey. Okay, so troubleshooting is very important, so that skill cannot be taught to anyone unless until you experience yourself. Okay, so I'm just sharing my experience on whatever issues that I faced, and it will be definitely saving your time and also reducing your escalations. Okay, so yeah, in the part 1 we just left at weight event histogram, right? So I just explained the individual time taken for each and every weight events, right? So if you see, there are different categories under weight event histogram. So we have up to 64 microsecond of weight, right, and 32 millisecond, and 2 seconds, and 2 minutes, right? So every section is showing you the same details. Okay, so yeah, in the last section itself I would have explained, so hope you would be getting something from this section. But this is the most underrated section, I would say. Okay, so if I just explain what is what, then it would be easy that you will easily understand, but you should know why these sections are there, right? So generally, if I explain that this weight event histogram prints each and every individual categories of time, right? So Oracle just categorized or split the individual weights, right, to differentiate what are all the weights which weighted for less than 8 microsecond, less than 16 microsecond, less than 32 microsecond, right? So that it will be easy for you to isolate the weight events based on the time taken for individual set of time. Okay, so in real-time example, you can take any example. Okay, so say for example, we have a counter, any counter you can take in a real-time. You can take a hotel, any restaurant, or you can take airport, right? So in each and every airport, if you see, there will be a set of queues for each and every counter. So this is counter 1, counter 2, counter 3, and counter 4, right? So when passengers or when the customers are coming into the queue, there will be individual executives who will be attending those customers or the passengers, right? And if you see, in the first counter there are 10 people, second counter there are 12 people, third counter there are 50 people, and fourth counter there are 6 people, right? So if you want to understand how much time it is taking for each and every customer or passenger to serve, okay, so you are just calculating the time, the start time. So say for example, if the counter starts at 10 a.m. It completes at 12 p.m. It takes 2 hours for say for example, so you can take an average 10 plus 12 plus 30 plus 6, so it would be around 58, right? Total for serving 58 passengers or customers, it is taking an average of 2 hours, right? So you are just calculating the average based on the total serving of each and every individual counter, right? And also based on the customers. So this is what the top foreground wait event section shows, right? If you go to the top, if you see this foreground wait events, it is showing average wait 13.37 milliseconds. So similarly, so you are calculating that for serving 58 customers, it is taking 2 hours. So this 2 hours is the 13.37 milliseconds. Okay, and this 58, the total 58 passengers, you can take the number of sessions which are waited for this resource manager, or you can take the number of waits. Anything you can take, you can compare. So I'm just giving you basic real-time example for understanding purpose. So there will not be any exact comparison, but yeah, the time taken will be exactly the same. So you are calculating the average, right? So how you will calculate the average? So the sum of number of persons divided by the total number of the persons. So something like that you will calculate, right? So yeah, let me come back to the example. So even Oracle calculates the average wait based on that. Okay, so the number of customers divided by the total time taken, or it depends on the metric that you are calculating. So what exactly you are looking for, right? So let us not go much into the mathematics part. Let us just stick to the performance, the AWR interpretation. So Oracle just calculates the total average like this, but we need to understand where exactly the exact time, more time has been taken, right? That is very important. Just because you are overall you are just saying that this counter is taking 2 hours, that does not mean that every counter, each and every counter are taking 30 minutes, right? So how if you just equally distribute the time, so one counter would take 30 minutes, another counter 30 minutes, another counter 30 minutes, another counter 30 minutes. So if you add up all these, you will get 2 hours, but that is not the reality, right? So this is just an assumption. So maybe one counter would have taken 1 hour, another counter would have taken 20 minutes, another counter would have taken 40 minutes, and another counter would have taken another 1 hour. Sorry, it's 2 hour, right? So yeah, it should be 30 minutes, 1 hour 50 minutes, and another counter would have taken 10 minutes. So here if you just split each and every counter, so this particular counter is taking more time. Okay, so we cannot say that if a counter is having multiple passengers, the counter would take more time. Even having max passengers or customers, still that counter would serve fast. And even if the counter is having 6 persons, it would sometimes take some time. So imagine any 1 or 2 persons are not having the proper verification. Okay, so you need some time to deal those things and all. So in those cases, obviously, even if I have less passengers, that does not mean that that counter will complete fast. So there are a lot of other reasons. So likewise, in Oracle also there are each and every wait events, okay, and each and every wait events will be the top foreground wait events will show you only the average milliseconds. That does not mean that every session consumed total. Let me just show you that the top foreground wait event section. If you see, it is showing overall the sessions consumed 13.37 milliseconds. This does not mean that each and every session consumed. So if there are 100 sessions, say for example, you just divide that 100 by 13, or you can take 10 sessions. If you just divide 13.37 divided by 10, right? So how much you will get? So each and every individual sessions would get almost 1 point something percentage of time, or milliseconds of time. This is not the truth, right? So just because there are 10 sessions and total average is 13.3 seconds, that does not mean that every sessions would be taking 1 point so and so. 1 second may take 7 milliseconds, other sessions may take point some less milliseconds, right, out of these 10, or one session would take 10 milliseconds and remaining sessions would have take like very less point not milliseconds. So it may be any case. So to isolate and show you the exact breakup of each and every session's weight, that's the reason we are having the histogram. Okay, so now you understood why we are having this histogram. So let us focus on the resource manager wait event. Yeah, if you see, so under the resource manager it says less than 8 microseconds, it is only 0.0. Total weights 1.89k, and less than 16 microsecond, how much? 0.0. So you need to check. So less than 32 microsecond, it is only 0.3. So where the time, most of the time is spent, 2.3. So if you go under 2.3, it is almost less than 256 microsecond. There is a most amount of time that is being spent. Okay, so out of this, greater than or equal to 512 microsecond, that is more than that, not 2.3, it is 93% of time that is spent greater than or equal to 512 microsecond. Okay, so if you see the amount of less, under the histogram for this bucket, right, less than 8 microsecond or less than 16 microsecond, these are very less. Only the amount of time spent greater than or equal to 512 microsecond is more. So you can get an idea that few of the sessions took only this much amount of time, but almost majority, 90% of the session has taken 93.1% of time. Sorry, it is 93.1. So this can help you in identifying the hidden layers. Okay, so for resource CPU quantum, this is just a normal weight event related to resource manager. But if in case of IO, right, any IO weight events, it will clearly help you in understanding the different categories of weight, and that can help you in isolating the issue, whether it is related to database issue or whether it is related to storage issue. Okay, so certain storages will have some standards, wait time standards. So in modern storage systems, 10 millisecond is the maximum time that is acceptable for any storage. If it is less than 10 millisecond, then the issue is something related to database. But if the storage is responding with greater than 10 millisecond of IO, then that means that the issue should be focused on the storage layer, right? So for those kind of situations, it will be easy to identify the hidden layers. So you can see, I will take one weight IO weight event, DB file sequential read. So if you see, the most of the weights are coming under the microsecond category. Okay, so even you can go to the next weight event categories and check. You can go and check the millisecond category. So in millisecond category, go and check DB file scattered read or sequential read. So if you see, less than 4 millisecond, it is 1.5, less than 8 millisecond is 5, less than 16 millisecond is 6. So this means that obviously there is some issue with the storage layer as well. But if you see, majority of the IOs are properly responded by the storage, 87.2, but still there are sessions where the wait millisecond is crossing 10 millisecond. So less than 16 millisecond means that it is obviously, it may come under between 8 millisecond and 16 millisecond. Or you can directly go and check 32. This will be easy for you to rule out, right? So less than 32 means it will be between 16 millisecond to 32 millisecond. So this means that obviously it crossed 10 milliseconds. So a few of the sessions are still not getting the proper response. So this can help you in identifying any IO problem. So if you see, majority of the sessions are under this 32 millisecond, less than 32 millisecond, this can easily help you to interpret that the issue is from the storage layer. But now we cannot easily say that the issue is from the storage layer, because almost majority of the sessions are less than executed less than 8 milliseconds. So only a minority, like 1 or 2% of the sessions are coming under the greater than 10 millisecond part. Okay, so you cannot get any direct clue or hint, but you have to create the hint by taking each and every metrics from these sections. And if you go to seconds, up to 2 seconds, so these are very worse. Okay, so here also, if you see less than 32 milliseconds, it is showing for DB file sequential read 99.3%. But that does not mean that all the sessions which waited under DB file sequential read are less than 32 milliseconds. If you go back to the previous one, you are seeing less than microseconds. You are seeing majority of the sessions waited under less than 8 seconds here. So less than 8 millisecond, you are seeing almost 90% of the sessions, right? So that's how you need to check each and every sections. But here if you see, it is directly saying that less than 32 millisecond, almost 99%. So this is not true, right? So when you get the cumulative data, that's where there will be some false or there will be some lies. So we cannot by directly seeing that when you directly see only this section, we will blindly interpret that almost majority of the sessions are only less than 32 millisecond, but it may be 1 millisecond also, it may be 30 millisecond also, it may be 8 millisecond also, it may be 5 millisecond also, the collection of sessions. Only few of the sessions would have wait under 16 to 32 milliseconds. That does not mean that all the sessions are IO contention, having the IO contention, right? Yeah, so this is how you need to compare each and every section. So if you see, even up to 2 minutes it is showing, up to 1 hour also it is showing. Okay, so next comes the service statistics. So service statistics means it will be quite useful in CDBs, multi-tenant containers, and also rack. Okay, so in a standalone, generally we don't use any service based. Only sys$ user and sys$ background will be the default service. Okay, and in a standalone database you will not be seeing the PDB and all. Yeah, but you will see the default service, the database service that you are using for connecting via TNS entry, right? And also the listener. So when the application user is connecting via this, you will be seeing these services. So here, based on the service, you can also identify whether sys is consuming more time or whether non-sys service is consuming more time. Okay, so here, since this is a test system, I executed every jobs using sys user, so that's the reason you are having DB time very high for sys. But in a real-time systems, you may see high DB time for the other services, the application services. And the next one is also service weight class stats. So this is specifically categorizing each and every class. So here IO class, here concurrency class, here admin class, here network class. So admin class means it comes under configuration. Okay, so based on the service, it is just doing a pivot. So which service under which class it is taking more time. So here if you see, almost majority are consumed under IO, and also service name is PDB. Okay, so you can also categorize by having an intersection between the service and the weight class. And next comes the channel. So channel, yeah, obviously if you are having RMAN, right, RMAN recovery manager. So when you are taking backups and all, you will be allocating some channels. So you can, if you are interpreting any backup related issues using RMAN, then obviously you can directly come and check this section. So this will just give some idea, that's all. And next comes the top process types by weight class. Okay, so this is also very important. So certain times you may need to understand which process, whether foreground or background or anything else. So here you can easily get the hint. Here if you see parallel query slave, job queue slaves. Okay, so rest of the process types are general. So log writer is mandatory background process, DBWR, checkpoint, PSP, CJQ. These are mandatory background process. So you can ignore these processes. But still, if you see DBWR on top of the process type, then that means DBWR is waiting onto something. So as part of your interpretation, you have to include this on your report, that DBWR is consuming more time. That means that you need to focus on the checkpoint and the IOs, because when DBWR is writing the dirty blocks to the data file, obviously when DBWR writes the dirty blocks, when a checkpoint happens, right? So when a checkpoint happens, when a log switch occurs, because one online read log file is full and it has to, log writer has to write to the next online read log. So it is a chain of issue. So you need to further dig each and every components of the database. So when a log switch occur, when there are 3 online read log files, this file 1 gets full, then there will be a log switch. So log writer will write to the next online read log file. So when the log switch happens, a checkpoint occurs. Okay, not that you should be already knowing, but still I am again letting you know. So log switch does not occur because of a checkpoint, but checkpoint occurs because of a log switch. So when the switch happens, the checkpoint occurs. When checkpoint occurs, DBWR will write all the dirty buffers. When DBWR write all the dirty buffers, there will be IO. So there will be a batch write, right? So immediately when DBWR writes, there will be a spike in the IO. So if the dirty buffers are very high, right? So you need to make sure that you are configuring your system in such a way that the checkpoints happen at equal intervals. Okay, if the checkpoints are frequently happening, that is also a problem. If the checkpoints are very rarely happening, that is also a problem. You need to check your system and make sure the checkpoints occur properly at regular intervals as per your system, because each and every system may be different. If the system is very busy, obviously a lot of checkpoints happen when multiple TML transactions happen. So you need to reduce the checkpoints. Why? Because if multiple checkpoints happen, obviously DBWR will be under pressure. So when DBWR is under pressure, there will be a lot of IOs, and also storage also will be in pressure. So during that time, you will be getting all the information in the top process types by weight class. So that's the reason I'm explaining this. So when checkpoint CKPT occurs on top, then further you need to dig whether there are a lot of log switches or not. And if DBWR is on top, then you need to check whether a lot of checkpoints are happening, what are the log switch intervals, whether frequent log switches are happening, whether when is the peak time of the DML, everything you need to check. And another thing is parallel. So if your system is consuming a lot of parallel, right? So here if you see parallel is on top, this means that my system is almost parallel consumed. So I need to check why parallel is used, whether it is used for legitimate purpose or it is unreasonable, like using it for some small jobs. So parallel should be used whenever the data set size is huge, when the table or when the select query is returning millions of records, right? So during that time I should use parallel. I should not use parallel for a simple query like returning 20 rows or 100 rows. And also job queue slaves. So this also means that there are some background jobs that are executed. So background job means, so there are auto tasks. Okay, auto tasks means the automatic optimizer statistics gathering, automatic segment advisor, and there is another. So I would have explained this in another session. So you can go and check the scheduler job section. So you will be able to get it. So I will be putting it in the description. Okay. Or it may be user created jobs. Okay, it may be anything. So you cannot blindly say that when job queue slaves are executed, auto task would be running. So auto tasks are the background or internal jobs, but even user can create scheduler jobs and they can run it concurrently, run the application jobs concurrently. So you need to further focus on the job perspective. So you need to check how many job queues are there, and what were the concurrent sessions, whether jobs were failing, how much time it is taking, how much resource it is taking. All these things you have to check. Okay, and yeah, CJQ is the job coordinator. So if you see, obviously the job queue slaves, CJQ will be the master process and job queue slaves will be the slaves which are coordinating with the job queue. And if you see M on the top, then that means there is some issue with the performance report collection. So we need to focus on the M1. Why M1 is taking this much time? Okay, so likewise there are lot of different individual issues that we need to focus in depth. Okay, but if you don't have time, you don't go and check each and every thing. What you need to check is the foreground weight event and just focus on reducing the weight. These are just hints. So resource manager CPU quantum itself will give you a hint, right? Why we are getting resource manager CPU quantum. So in the weight event name itself we are having CPU. This means there was a high CPU, and because of the high CPU, since I enabled resource manager, so resource manager's job is to cap the CPU. Cap means it will just limit the CPU. So if my CPU crosses 75%, if I set the configuration in the resource manager to tell that resource manager that, hey, resource manager, don't allow any session to consume more than 75% CPU. If it has hit 75%, then just cap it. Just have a layer on top of it, so that it does not go above that, right? So sometimes if any session is unnecessarily consuming 100% CPU, then your database will get saturated, right? So that's the reason resource manager is configured. So resource manager itself will give you a hint that there is a CPU. Okay, so if there is high CPU, what are all the reasons for high CPU? Parallel, right? So yeah, this gives you a good understanding that resource manager weight event occurs. Obviously there will be a parallel issue. So next section is very important, and obviously you should not ignore this section, right? So SQL. So all these are based on the individual metric related to a SQL. Okay, so this is the core of every AWR. Okay, end of the day, no matter whatever section that you check, you have to end up with the SQL, right? So SQL is the one which is executing on the database. So obviously what requires the resource? SQL is the one which requires the resource. Either it may be CPU, or either it may be IO, either it may be logs, either it may be parsing. Okay, so there are a lot of categories, so those categories are divided here. Okay, so yeah, obviously if you you can take any real-time example. So you are using your car. Okay, so what is the core part of the car? So either it may be electric or it may be petrol. So you can take these two, electric and the petrol, as the resource, right? So the car will be the database, and you are the SQL. So I am the person who is riding the car will be the SQL statement. You can imagine like that. Okay, so yeah, when you are switching on the car and when you are driving the car, you are utilizing the car. So similarly, when the SQL is executing on the database, it is utilizing the database. So obviously the database should have some resource. So likewise, the car requires some resource, petrol. So if the petrol is exhausted, then you need to go and put on the petrol bunk. So likewise here, there will be no petrol bunk. It will, once the resource is cleaned up, automatically it can be reused. So like you can take human body as well, right? So you are eating food, so based on the food you are taking the energy. So CPU, IO, logs, these are all similar to food that you are consuming. Okay, so you are the database, the person is the database, person consuming all the food or the resource. The food is the resource, food and water, and I am doing some task. I am lifting weights, or I am jogging, or I am carrying some groceries to one place to different place, right? So these are the jobs. So that's the reason there are different categories. So based on the weight reason, right? So you need to further drill down. So we already know that the weight event is resource manager CPU quantum. So you don't need to go and check each and every individual sections. So you already know the weight event. So, and also the cause and the reason. Resource manager, why resource manager CPU quantum weight event happen? Because of CPU. So you directly go and click on the SQL ordered by CPU section. And in that you can see the first SQL. Obviously I already mentioned parallel will consume CPU. So in the select query itself there is a hint, parallel 32, and also previously we checked the process by top CPU used and process by weight class. So here also if you see, we see job queue slaves. As I already mentioned, there will be either user specific configured job, or it may be auto task jobs, right? So even in top type process types by CPU used, we have parallel slaves and job queue slaves. So that clears our interpretation. So here SQL module is DBMS scheduler. So DBMS scheduler means it is a user configured job. So I need to check why user has configured this job, and whether the job is properly executing, and why we need 32 parallel. All this information we need to check whether we have the sufficient parallel settings on our database, right? So without understanding all these things, we cannot further move ahead. We need to check with the application team why this much parallel is required, whether it is critical or immediately required, right? So all these details need to be checked. So next comes the complete list of SQL text. So it gives all the SQL ID and the SQL text. Next comes the instance related activities. So instance related activities will give you all the metrics and the statistics related to the database. So this is not related to weight events. These are the individual statistics, right? So how many block got changed? So this will give a hint on the redo logs. So obviously block changes will happen because of the redo logs, right? So why a block change? A block change because of any DMLs, insert, update or delete. So when insert, update, delete happens, the block will be changed in the buffer cache. So when the block changes in the buffer cache, obviously there will be a lot of redos, right? So you have to check the buffer cache as well, and also a redo perspective. So likewise you have a lot of other metrics, parsing related, how many logons, physical reads, physical writes, redo size, user calls, user commits, user rollbacks. So these individual metrics I will explain in a different session. Okay, so based on your response I would dedicate individual sessions for each and every issues. Okay, so these three are very important: user calls, user commits, rollbacks. So this gives the arrival rate of the database. Arrival rate means the workload. So you need to calculate based on the user calls, how you calculate the arrival rate, how you calculate the service time. So that needs another separate session to explain. So these are the individual statistics. So this gives only high level statistics information, but here it gives the individual statistics related to the background and the foreground process. It gives very depth information. Okay, so next comes the absolute values, like the memory information. So how much memory has been consumed from the start till the end of this AWR, the snapshot. And next comes the log switches. So this is also very important. So when you are focusing on any log the redo related information, you need to check how many log switches happened, but here it is very less. Okay, so I will again give us dedicated session for log switch interpretation. So here we don't have anything, but we have some calculations and estimations for log switches. So based on that, we need to further interpret. Okay, so yeah, next comes the IO stat. So I will just stop this report by from this section. So I will just put a part 3 of this AWR interpretation section. Okay, hope you like this video. Just subscribe this video if you want more learning sessions related to your work. It will not be theoretical, it will be a practical videos. Okay.